Just 4 light-years from home, a stone's throw in cosmic terms, we found it, a planet that could be Earth's twin. It's rocky, about the right size, and orbits in the Goldilocks zone of its star, where liquid water could exist. But hold on, this isn't the paradise you might be picturing. This world is probably locked in a gravitational stare-down with its star, leaving one side scorched in eternal daylight and the other frozen in unending night. The real question is, could anything actually live in the twilight between those two extremes? Back in 2016, our little corner of the universe got a whole lot more interesting. Astronomers using the European Southern Observatory in Chile confirmed a planet orbiting our closest star, a dim red dwarf named Proxima Centauri. They called it Proxima b. This wasn't just another speck of dust in the cosmos. At a mere 4 light-years away, it's the closest planet outside our solar system that we've ever found. The discovery wasn't made by seeing the planet directly. It's too small and dim for that. Instead, scientists watched its star wobble. Using the radial velocity method, they spotted a tiny, rhythmic dance in Proxima Centauri's light. It was the telltale sign that a planet's gravity was pulling on it. The data that came back was electrifying. Proxima b has a minimum mass just 1.07 times that of Earth, strongly suggesting it's a rocky world like ours. What really got everyone excited was its location. Proxima b orbits its star at a distance of only 7.5 million kilometers, way closer than Mercury orbits our Sun. But because Proxima Centauri is a cool, faint red dwarf, this cozy orbit places the planet right in the middle of the star's habitable zone, that sweet spot where temperatures might be just right for liquid water. For a moment, the dream of a second Earth right next door felt intoxicatingly real. Here was a world, almost our twin, in the perfect place. But as we looked closer, the beautiful idea of an Earth-like paradise started to fall apart, revealing a planet of brutal extremes. The first huge challenge for life on Proxima b is something called tidal locking. It's highly probable that, just like our moon always shows the same face to Earth, Proxima b is stuck in its orbit, with one side forever facing its star and the other cast in eternal darkness. This isn't confirmed, as some complex orbits could be possible, but it's the most likely scenario. If so, it creates a planet split in two, a world of endless day and unending night. Imagine standing on the day side. The red sun, Proxima Centauri, would hang frozen in the sky, baking the landscape under a relentless, scorching glare. Any water here would likely boil away, leaving a cracked, sterile desert. Now flip to the night side. A world without a sunrise, forever trapped in the black of space. Temperatures here would drop to unimaginable lows, wrapping the surface in a thick blanket of ice. It could be so cold the atmosphere itself would freeze and fall as snow. But the planet's problems don't stop there. Its parent star, Proxima Centauri, is no gentle sun. It's a volatile red dwarf, known for its violent temper. Red dwarfs are prone to powerful stellar flares, sudden massive blasts of energy. Proxima b gets hit with about 250 times more X-ray radiation than Earth. A single one of these super flares could unleash a torrent of high-energy particles, strong enough to strip a planet's atmosphere away over time. Without a protective atmosphere, the surface would be sterilized by its own sun. The dream of a habitable world seemed to be dying, scorched by day, frozen by night, and blasted by radiation. But the story isn't over. Where there are challenges, science often finds possibilities. The very thing that makes the planet so bizarre, its likely tidal locking, might also be its saving grace. Between the scorched hellscape of the day side and the frozen wasteland of the night side lies a sliver of hope, the Terminator line. This is the zone of perpetual twilight, a narrow band circling the planet where the red sun hangs forever on the horizon. In this eternal sunset, temperatures could be moderate enough to escape the brutal extremes of either side. It's here, in this twilight zone, that liquid water could potentially flow in rivers and pool in lakes. If life exists, this is where it might have found a foothold. Of course, water doesn't mean much without an atmosphere. So how could a world so battered by radiation hold on to its air? The answer might be deep inside the planet. If Proxima b has a molten, rotating core like Earth's, it could generate a powerful magnetic field. This would act like an invisible shield, deflecting the worst of the stellar winds and protecting the atmosphere. While speculative, some models suggest that even with early, intense radiation, Proxima b might have held on to a good portion of its initial water. If life did arise, it would be truly alien. Photosynthesis on Earth is tuned to our yellow-white sun. On Proxima b, any life would have to adapt to a light spectrum dominated by red and infrared light. Plants, if they existed, might be black or deep purple to soak up every possible photon from the dim red star. Life here would be forged in a crucible perfectly adapted to a twilight existence under a violent crimson sun. For now, Proxima b is a world of educated guesses and complex models. We can't see its surface from 4 light-years away, but we're on the verge of a new era of exploration that could turn theories into facts. Our most powerful tool is the James Webb Space Telescope. With its incredible sensitivity to infrared light, Webb can analyze the light from Proxima Centauri that might pass through Proxima b's atmosphere if it has one. This could reveal chemical fingerprints of gases like water vapor, methane, or oxygen, potential clues of life. In fact, some recent observations have already caused a stir, with reports of unexplained illuminations and thermal anomalies on the planet's surface, though scientists are still working to figure out what these patterns mean. But even Webb has its limits. To truly know Proxima b, we need to go there. This is the goal of one of the most daring projects ever imagined, Breakthrough Starshot. The plan is to build a fleet of tiny gram-scale nanocraft, each attached to an ultra-thin light sail. A massive array of ground-based lasers would fire a beam of light at these sails, accelerating them to an incredible 20% of the speed of light. At that speed, the journey would take about 20 years, not thousands. The tiny probes would fly past the planet, snapping pictures and gathering data before sending it back home. The project faces huge technological hurdles, and its status has seen slowdowns, but the ambition to reach for the stars remains. Proxima b is a planet of paradoxes. It's so close and yet so far. It's a world with conditions that are both tantalizingly promising and deeply hostile. It's the perfect symbol of our search for life, a search filled with hope, loaded with challenges, and driven by our need to know our place in the universe. The planet hangs there in the darkness, a silent reminder that worlds like our own might be common, but a paradise is likely rare. Whether it's a barren, irradiated rock or a living world huddled in the twilight, remains one of the great mysteries of our time. The fact that we can even ask these questions about a planet orbiting another star is a triumph. Proxima b reminds us that the universe is far stranger and more wonderful than we can imagine, and that just next door, an entirely new world is waiting to be understood. Our journey to understand Proxima b is just getting started. Every new piece of data brings us closer to answering the ultimate question. If you want to follow this incredible story of discovery in our own cosmic backyard, make sure to subscribe and ring that notification bell for more explorations into the unknown.